Hello. Wait, did you just say test? Yeah.
Your Zoom's working.
I see. Hello. Wait, did you just say test? Yeah.
Your Zoom's working.
I see. Hello. Wait, did you just say test? Anyone else joining?
Your Zoom's working.
I see. What do you mean? Yeah, on Discord. Are we asking other people right now? Let's see. Guys.
Yo.
Oh, we meant the Zoom, but you can stay in here too. Join the Zoom.
Wait, where's the Zoom link?
Did you get some people to? Do you know some people that are gonna be attending?
Yo. Yeah, I asked some people.
Oh, we meant the Zoom,
Do they
but
know
you
how
can
to
stay in
access
here
it?
too. Join the Zoom.
Wait, where's the Zoom I link? just told them about the story, or not the story,
Can you send them the link
Yeah.
as well? I think that would help.
Okay.
Like also us to remind them as well. Did you get some people to? Do you know some people that are gonna be attending?
Yo. Yeah, I asked. Do we ever learn how long the Q&A was gonna be?
15 to 30 minutes, but it also depends on how many people are asking questions.
Okay.
More than 3 decades ago, Jeff Anderson brought one of the first lawsuits against the Catholic Church.
Hello, Brian. You're muted.
Hello.
Hello. I won't be the presenter for this meeting. It'll be Lickit.
Okay. Now, I wanted to ask whether you want to have it as a conversation. Are you recording it? Whether you want me to make a presentation? What's the format?
So we were thinking that you could initially maybe have a presentation, and then we'd have like a Q&A section at the end where we have any questions about the presentation or other topics that you've been studying. We can ask that, and also
Okay.
get those questions from the
So the purpose, you want to learn about my research, or do you want more, to ask me about the career in science? What's the purpose of the meeting?
I think mainly it's about the research, maybe the Galileo
Okay.
project, and like other
Okay.
things regarding that.
Okay, sounds good. So I'll speak just for half an hour or so, less, or even less, just to allow you to ask any questions you want. Do you want to record it? Hello? You muted yourself, whoever
Oh, sorry.
spoke. Yeah.
I think, yeah, we want to record it.
Okay, and how many do you expect? There are 25 so far.
Yeah, I think we wanted around like 30-ish. 30 to
Okay.
40.
And what do you do with the recording after that?
So we're probably gonna post it on our Instagram and our maybe our website, and try to spread it around as well, so other people who want to learn more about your presentation can.
Are you from one high school or many high schools around the country?
Several.
Which states?
I believe California, and New York, Texas. I think that's it.
Okay.
Also, we have some international members as well, from Kazakhstan, Turkey, and United Kingdom as well.
Okay, so I will speak for half an hour or so, and then let you ask questions, okay?
Okay.
I'll try to limit, I will not present all the slides that I have. I'll try to limit it so that we have time for your questions.
All right. Sounds good.
Okay, so whenever you want to start, let me know, and then you can start the recording, and I'll you should enable me to share my screen. You can make me a co-host. Okay, great. So I think now I'm allowed to share the screen. Okay, so you just need to start recording whenever you want, and then do you want to present me or just let me start immediately?
I think the recording already started, and we just have like a brief intro.
I don't think it started because usually it tells, it says you're being recorded or something like that.
I think we're using like a different like outside source for the recording instead of the Zoom.
Why not use the Zoom for the recording? You can just record it on Zoom. It goes to the cloud, and then you don't need to do anything outside. Do you know how to do that? If you are the host, you just go. There is a place here to record. If you go to more.
Okay.
You see that?
Yeah.
So all you do is just press that button, and then it will send you an email with a link, and then you can get the link and make it available to anyone.
Ricky, you're the owner of the meeting, right? Can you do the recording thing as well? Because I don't think I have the permission to.
So whoever is the host, who is the host?
I think you have it now.
No. So don't give me. Okay, we should make co-host, not make me the only host. You should also be the host. So you gave it to me, and now you cannot get it back. Is that right?
I think so. Yeah.
Okay. So who do you want me to share it with? Who should be the recorder? Because I can make any of you co-host. So that
I think Ricky Ho.
Okay, let me find Ricky. There are many people on it, so I don't know who is Ricky. What's the name exactly?
Ricky Ho. He has a profile picture as well.
Oh yes. Okay. Okay, so I'll make you the host so that you are the primary host. I think you are now the host, and just make me a co-host. Okay? I'm changing you to the host, and you just make me a co-host, so you're still the host. And then you can record it. Did you get me? Did you get the transfer?
Ricky, did you get it? Okay.
Okay, so just make me a co-host so that you remain the host, and then you can record it. The only option? Okay, why don't you start recording and then transfer it to me?
Recording in progress.
Okay, and now try to make me a co-host. Okay, so we can start whenever you want.
All right. Lavanya, you want to start?
Yeah. Hello, everybody. Thank you so much for attending the speaker series event featuring an eminent theoretical physicist, Dr. Avi Loeb. As a bit of background, Dr. Loeb is a Frank B. Bard Junior Professor of Science at Harvard University, and he is the founder of Harvard's Black Hole Initiative. Some of his prominent research deals with the nature of black holes, and of special focus for us today, the search for extraterrestrial life.
So I believe he's here today to talk to us about the Galileo project and other research he has. The Galileo project, if you guys didn't know, is an organization dedicated to analyzing evidence of interstellar objects and unidentified aerial phenomena in a search for extraterrestrial civilizations. Now we're going to hand it off to Dr. Loeb for his presentation, after which we will be having a Q&A.
Thank you very much. And I'll try to limit my comments to less than half an hour so that you will have a lot of time for questions. Let me share my screen so that you will be able to see my presentation. Okay, so what I'll talk about are some elements of my book, Extraterrestrial, that came out about 1.5 years ago. You see the cover in the middle. And if I had to summarize it, I would say, when you're not ready to find exceptional things, you will never discover them. And I will clarify in a few slides what I mean by that. What you see on the left side is a photograph of a picture that was hung on the walls of the Berlin-Brandenburg Academy of Science and Humanities. It was taken by a German photographer, Herlinda Quilbel, who came to my office at Harvard and asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" Now, it turns out that this question is of great interest also to people engaged in religion or spirituality. I received an email just a couple of months ago from a rabbi that told me that she gave a Word of Torah a sermon inspired by my book, Extraterrestrial. And the conclusion is that the frontiers of science and spirituality share a common thread, which is exploring the unknown. And what I'll describe is a project that I established about 1 year ago called the Galileo Project. And you can see here a group photo from a conference we had at the beginning of August this year to celebrate the accomplishments of the project. It's such a great privilege and pleasure to see 70 members of the Galileo Project team coming together, celebrating the past year accomplishments of the project. And we are just at the beginning, because in the coming year, we hope to collect data and find out what it shows. We make no assumptions, we are completely agnostic, but it seems like the government is telling us that there are some exciting objects out there that we need to figure out what they are. And that's our hope.
For now, we assembled the relevant instruments, we're testing them, and we will soon deploy them and start collecting data. Because the sky is not classified, and we very much hope to discover what the nature of objects that the government is talking about and that astronomers are talking about that look like outliers are. Are they technological in origin from another planet, or are they natural phenomena? And the Galileo project aims to find out along three tracks. One is looking at unidentified aerospace phenomena in the sky and imaging them in the infrared, optical, radio, and audio bands. The second is rendezvousing with interstellar objects in space and taking a close look at them. It will cost about $1 billion to meet an interstellar object. There is a much cheaper way of doing that, and that is to find an interstellar meteor. We know of one that landed near Papua New Guinea in 2014, and we plan to search for the fragments from this meteor by scooping the ocean floor. And that is the third branch of the Galileo project. So we have very exciting times ahead, and we look forward to what we will find.
So just a few words about science. What have we learned over the past century? The biggest message we got from the universe is that we should be modest, humble, because we know that about half of all the stars, like the sun, have a planet the size of the Earth, roughly the same separation. So the conditions we find here on Earth are not unique or special. And when I see an emperor or a king conquering a piece of land and being very proud of themselves in human history, I'm surprised, because that is not very impressive. It's just like an ant hugging a single grain of sand on the landscape of a huge beach, because there are more grains of sand on a beach than there are roughly the same number as there are habitable planets in the universe. But I can understand where this hubris is coming from, because my two daughters, when they were young, they thought that the world centers on them. And when we took them to the kindergarten, they realized that there is a smarter kid on the block, and that was a psychological shock for them. So the question we want to ask is, are we the smartest kids in our cosmic block? And of course, if we find that we are not, that would be a major development. It would mature our civilization. And Albert Einstein was probably not the smartest scientist who ever lived in the history of the universe since the Big Bang 13.8 billion years ago. What you see here is a cartoon of that was drawn when Einstein died, and it shows the Earth with a plaque on it. Albert Einstein lived here. But as much as we are proud of that, most likely there is another planet that had a civilization like ours billions of years ago, because most of the stars formed billions of years before the sun. And the civilization who benefited from such a scientist could have sent probes that would have arrived here by now. So that means that we might not be alone. And moreover, we can find evidence, we can find packages in our mailbox from other civilizations. So that's what the Galileo project is trying to find, equipment from other civilizations. And it turns out that only over the past decade, we started finding objects from outside the solar system. The first report came in 2017 from a telescope in Hawaii that discovered an object called Oumuamua. This name means a scout in the Hawaiian language. And at first, astronomers thought, well, maybe it's a rock from another star. Turns out that it's very peculiar. And I will talk about that. But it was not the first object, because 4 years earlier, the US government discovered a meteor, an object that exploded in the atmosphere when it collided with Earth. And this meteor was moving so fast that it must have arrived from outside the solar system. It was discovered on January 8th, 2014, near Papua New Guinea. And we are planning to go there because the government released also the light emitted by the fireball that was created when the object burned up in the atmosphere. And from that, we inferred that its material strength was tougher than iron. There was actually a second meteor that we discovered with my student from March 2017.
My name is Avi Loeb, professor of science at Harvard University. In the coming months, I'm going to lead an expedition to Papua New Guinea to scoop the ocean floor and search for fragments from the first interstellar meteor.
Although Avi is in search of what he believes may be alien technology, proof of extraterrestrial existence has never been what's driven his life's work until now.
I'm hopeful we will find something. The question is, what is it? An unusual rock, a natural object, or artificial?
Despite being the longest serving chair of Harvard University's Department of Astronomy, it wasn't until recently that he started to investigate the possibility that there is life beyond our solar system.
I found the catalog that the government compiled of meteors that were detected by government sensors that are missile warning system. I asked my student to check if any of the meteors, the fastest moving meteors, could have arrived to Earth from outside the solar system.
There was one in particular that sparked the interest of Loeb and his students, Amir Siraj.
We decided to write a paper about this meteor, which was discovered on January 8th, 2014. Light from the explosion was seen by government sensors.
Despite the government releasing limited data, he had discovered something groundbreaking. His paper laid out what he believed to be true. But 3 years after writing his findings, a major development confirmed what he knew all along.
After a few years, the release of a letter from the US Space Command in the Department of Defense stating explicitly that this meteor at the 99.999% confidence level came from outside the solar system.
Based on the speed of the meteor and how much of the object burned upon entry, Avi determined that it must be made of a material that is tougher than iron.
And so this one was an outlier in terms of its composition. It was also an outlier in terms of its speed outside the solar system. It moved at least twice as fast as stars move relative to the sun in the vicinity of the sun.
Armed with new evidence validating his findings, Avi decided to take action and make moves to recover the object, his next hurdle. Funding through private donations, he has secured a portion of the money to take the trip.
Let's continue to look for objects like it. It was obvious to us that we need to go there and collect the fragments, because to do the same thing for an object in space would cost more than $1 billion. For a cost that is 1,000 times lower, we can go to the ocean floor and collect material from an interstellar object.
Now, Avi has the task of finding an object that most likely fractured on impact, leaving fragments possibly the size of pennies lost at the bottom of the ocean. It's a challenge that might seem insurmountable in the vast existence of the Pacific Ocean, but Avi is confident they will recover what they are in search of.
It's a fishing expedition, literally speaking, and what we can do is basically take the trajectory of this meteor and extrapolate it all the way to the ocean surface. Now, of course, when the explosion took place, there were fragments generated and they were scattered over a region. One imagines that the tiny pellets would be carried farther away from the point of impact, whereas the heavier fragments will sink down closer to the impact. Finding a big chunk can inform us much more about the structure of the original object. We're planning to board the ship and build a sled and a magnet attached to it that will scoop the ocean floor, and we will go back and forth like mowing the lawns across the region 10 kilometers in size and collect with the magnet all the fragments that are attracted to it and then brush them off and study their composition in the laboratory. This will be the first time that humans put their hands on the material that makes an object that came from another star.
With more advanced technology in our skies than at any other point in history, new findings are becoming far more frequent and impossible to ignore. Thanks to a government report that was released last year, the possibility of extraterrestrial life and the pursuit of proof of its existence is finally losing its stigma.
The stigma has been reduced. It would be the most important scientific discovery that humanity ever made, because if you think about
Oops. Sorry. Someone just entered our waiting room, and so as a result, the video jumped. 1 second. I'll just go to this the place where
the technologies, we just need to use our telescopes and find out. In fact, we are not even the first to say that. Galileo Galilei said that 4 centuries ago, and he was put in house arrest. Today, he would have been cancelled on social media. Once I realized that we found an object from a technological origin that was produced elsewhere, I would not seek approval from anyone else. I don't need likes on Twitter. I just want to know what it is.
Okay, so as I mentioned in this video, we're planning an expedition to scoop the ocean floor with a sled and a magnet and look for the fragments of this meteor, because it was tougher than iron, and maybe it's part of a spacecraft that arrived to Earth from another civilization. And that's what we plan to find out. In about 5 months or so. As I mentioned at the beginning, the first object reported was not this meteor, it was Oumuamua in 2017, and it was roughly the size of a football field. It didn't collide with the Earth. It was discovered by reflecting sunlight, and it looked really weird because first it started in a very special frame, which is the average of all the stars in the vicinity of the sun. It wasn't moving in that frame, and sort of like a buoy on the surface of the ocean at rest. And then the sun collided with it and gave it a kick by the force of gravity. And the amount of light reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And the best fit to the variation was that of a pancake-like object, a flat object, which is very unusual. And then it was pushed away from the sun by some mysterious force, even though there was no evaporation of this object like you have in comets. There was nothing seen or detected. And so I suggested maybe these anomalies imply that this object is artificial in origin. Maybe it's a sail, a light sail, being pushed by sunlight. And that's why it looked so weird. And of course, nature doesn't make such things. So the suggestion was that it's artificial in origin. Now, it turns out that such an artificial object was actually, should be expected if we imagine walking on the beach. Most of the time we find rocks or seashells that are naturally produced, but every now and then we might find a plastic bottle, and perhaps that was Oumuamua. And it turns out that the same telescope in Hawaii, 3 years later, discovered another object that shared the same qualities. It was pushed away from the sun by reflecting sunlight, no cometary tail. It was given the name 2020 SO. And then the astronomers who discovered it realized that it actually came from Earth. It was launched by NASA in 1966 as a rocket booster. And we know that we produced this object. It had thin walls. It was made of stainless steel. The question is, if Oumuamua was something like it, who produced Oumuamua? The way I think of this is like a cave dweller that is used to playing with rocks, finding a cell phone. And obviously, the cave dweller would argue that it's a rock of a type that he had never seen before. But if he was sufficiently curious to press a button, he would realize that it's not a rock. So that's the lesson that we should draw, and I would love to press a button on such an object.
You are well in the lead at 4,400. How much would you like to wager? Let's do 2,000, please. Here's your clue. I look at the world and I notice it's turning, thanks to this man who studied at the University of Krakow in the 1490s. Who is Brian? No, correct response. Who is Nicholas Copernicus? You lose a little bit. Pick again, Robin. Scientist for 600. We think of this Russian who became a professor of general chemistry in 1867 periodically. Robin, who is Mendeleev? Yes. Scientist for 800. Avi Loeb thinks a space object seen in 2017 and artistically depicted here comes from this 16-letter type of being, the title of his book. Kevin.
What is extraterrestrial?
Correct.
Scientist for 1,000.
Okay, so maybe we should stop here. I have more slides, but I prefer to answer your questions. So you got the basics of what the Galileo project is all about from the videos and the presentation so far. And I would like to allow you to ask me any questions you have about this, about physics more generally, about space science, exploration, the universe. Any question you have, just ask. Please go ahead.
I have a question.
Yes.
Do you know how people found out the size of the Oumuamua?
Well, we know how much sunlight it reflected, and we know the distance. So because we monitored its orbit using Newton's law of gravity. You can infer the distance at any given time based on its speed on the sky, and so we know the distance and we know how much sunlight it reflected. The only thing you need to assume is the reflectivity, the reflectance, which fraction of the light that is impinging on the surface is being reflected, and based on that you can infer its size because you know how much light it reflects. So let's say it reflects 10% of the light that is falling on it. Then from the amount of light, we know how much sunlight is falling on it given its distance from the sun, and then we can tell its size. And so that implied the size of the order of, if it had 100, if it was a mirror, it would be roughly 20 meters in size or 60 feet. But if it was 10% reflective, then it should have been 3 times bigger. And if it was 1% reflective, then it should have been 10 times bigger than that. Okay, so roughly the size of a football field, because most objects have 5 to 10% reflectivity. So the size of a football field.
Okay, thank you.
You said that the asteroid was tougher than iron. I would like to know how this like further relates to it being likely extraterrestrial.
Well, we know that it's extraterrestrial. I mean, the word terrestrial means from Earth. Okay, so we know that it's extraterrestrial because it didn't come from Earth. Okay, and it was moving faster than the escape speed from the solar system. So it was moving so fast that it couldn't have been bound to the sun. Okay, so obviously it came not only from outside the Earth, but from outside the solar system, because it was not bound. You know, the planets like the Earth are bound to the sun. The reason the Earth moves around the sun every year is because it doesn't move fast enough. If the Earth, if you would have connected the rocket to the Earth and gave it a much larger speed, it would escape the sun, okay, the pull of the sun. And so this object was already moving at that kind of a speed, faster than can be bound to the sun. And that's, by the way, how we launch rockets. We just give them a big enough velocity above the escape speed from the Earth. And so they escape from the gravitational pull of the Earth. If you throw a tennis ball up, you usually cannot throw it fast enough. So it goes up to some height and then comes back again. But if you were to throw it with more than 11 kilometers per second speed, then it would escape the Earth. And the same is true for the sun. If you throw an object or launch a rocket moving faster than 42 kilometers per second at the location of the Earth, it would fly out of the solar system. And we sent 5 probes faster than the escape speed from the solar system, and they will run out of it. The first was Voyager 1, and then Voyager 2, Pioneer 10, Pioneer 11, and then there was New Horizons most recently. So 5 probes are making their way out, and it will take them tens of thousands of years to leave the solar system entirely. So we know that this object, based on its speed, came from outside the solar system. And with respect to the material, we know that it maintained its integrity all the way down to the lower atmosphere of the Earth. So it was able to resist the stress that was exerted on it by the atmosphere. And from that, we infer the material strength. So if it was much less tough than iron, then it would have burned up very high in the atmosphere, given its very high speed. And what we found is that it was not only tougher than iron, but tougher than all the space rocks in the catalog of meteors that the government compiled, 273 of them. So it was definitely very unusual. And what we want to find out is whether it was unusual, but made of some natural composition, or maybe it was made of some artificial alloy that allowed it to be very tough, such as stainless steel, for example.
I have a question.
Yeah,
Do
go
you
ahead.
ever face adversity in like gaining support or funding for your like specific field of like extraterrestrial research, especially for like the expedition you're having in the 5 months?
Well, there is no funding from federal government at the moment. That there used to be for the search for radio signals. You know, for 70 years, astronomers have been trying to detect a radio signal from other civilizations, and that's just like waiting for a phone call. What we are doing now is very different from that. It's like going to your mailbox and checking if there are any packages in it. And these two search methods are very different. And this second one, looking for objects that are technological in origin, that came from another civilization, that was never funded by the US government as a research program. There was never funding for it. So all the money that I'm using to support the Galileo project comes from the private sector, from individuals that are wealthy, that decided to that are either inspired by my book or are inspired by the vision of looking for these things. And there are many of them. And I was able, for example, to fund the expedition that we are planning to do in 4 months, 5 months. There was a very wealthy person that said, you need $1.5 million, you have it, no problem. So, but of course, in the future, I hope that this subject will get into the mainstream and also receive funding from the standard funding agencies.
Well, when you were publishing like your work on this subject, did you expect it to get this much private support?
No, I did not ask for private support. I did not fundraise. People came, that was during the pandemic when my book came out, and some multi-billionaires came to the porch of my home and decided to give me the money. So I was surprised. It was not my initiative. So but that allowed me to establish the Galileo project.
Hello. So I had a question. So if we could find convincing evidence of extraterrestrial civilization, what do you think that our next steps would be to address that?
Right. So in the past, people thought about detecting a radio signal. And in that case, it takes tens of thousands of years for such a signal to cross the Milky Way galaxy. So we would have plenty of time to respond to it, and we shouldn't feel any rush. But in the case of a visitor in our backyard, that especially if it involves a functional device, some device that has maybe artificial intelligence that is seeking some information, a probe, in that case, we need to respond immediately. And we don't have a protocol. We don't have an organization that represents humanity. And I think the next step, if we find something like that, and actually, as mentioned in one of the videos, the US government is talking about objects that they cannot really identify. And as a result of that, if we do find that one of them came from an extraterrestrial origin, then perhaps we should first passively seek information about what is it doing, what are the characteristics of this object, what kind of information is it seeking. And once we get that kind of a data, we can then decide what to do about it. And it's not an easy question because we need to figure out what the intention of this object is. But I should say that it's sufficient to have one object that is of this category for this to make a huge difference for the future of humanity, because at that point it will be clear that we are not alone and that there may be a smarter civilization out there. And so even if most of the objects we find in the sky with the Galileo project are either natural or human-made, it's sufficient for one not to be of this class, that for this to make a huge difference. So I think it's one of the most consequential discoveries that science can make for society.
Hi, I'm Gianna Garza, and I have a question. You opened your presentation with a statement from a rabbi and have mentioned aspects of spirituality throughout your presentation. I'm curious as to what role spirituality plays in your research and studies, because oftentimes I feel as though spirituality and science are more contradictory, or are seen more as contradictory than complementary.
Yeah, that's true, because, and there is a good reason for that, because there are some religious texts that make statements about the universe, and the universe is also a subject of scientific research. And what we find is some details about how the universe started, which are in conflict with some texts. Just to give you an example, in the Old Testament, the first chapter talks about what happened at the beginning, and it says that light was created in the first day after the universe was created. And the thing is, if we think of light as coming from the sun, it turns out that what we know now about the big, the universe, the early universe, in the first day, the temperature of the universe was hotter than the temperature at the center of the sun. So clearly there couldn't have been stars around in the first day after the Big Bang, okay? And that has to be modified. You can argue that the text didn't really mean a day, but if you take it at face value, that is in conflict with what the Big Bang data shows us. I mean, we know that the temperature in the first day after the Big Bang was higher than the temperature in the core of the sun. So stars did not exist. Stars formed only about 100 million years after that. Okay, so very long after, not the first day, 100 million years. Only then the first stars formed. And we can actually see them now with the Webb telescope. We can actually see the first stars. So anyway, the way I think of this is that as long as spirituality does not make statements about the reality that we can examine with science, they can live together. There is no, because in particular, let me give you an example. Suppose we discover an advanced scientific civilization they may be much more advanced than we are. It's very likely that they will, because we just had 1 century of modern science, and another civilization could have had thousands of years, or maybe millions of years, or maybe even billions of years. So they may be far more advanced than we are. And we are already getting to a point where we will create life in our laboratories. So they probably can easily create life in their laboratory. They might even understand physics so well that they can create a universe in their laboratory. So in that way, a very advanced scientific civilization could be an approximation to what we called God, because they are capable of doing things that look like magic to us. And this is an interesting way of bringing together religion and science. A very advanced form of science may look to us as a representation of God, because it would be capable of doing things that we cannot imagine. It's just like, if you imagine a human from 1 million years ago coming to visit New York City and walking in the street and seeing all the gadgets and everything that is going on, it would look like magic to that human, because everything around looks strange and unusual. And so we would have the same experience, and it might look like a miracle to us, many things that we encounter, because we don't understand science to that level. And so that's an interesting way. If we ever encounter a very advanced scientific gadget, it would unify what we meant by God in religious texts with very advanced science. So in principle, science and religion can come together after this encounter. And that's another way of putting together spirituality with science. But in general, I think both of them, as long as they're engaged in exploring the unknown and are not talking about the same thing, they can live side by side.
Thank you.
As you were talking about like other civilizations, I wanted to ask about the idea of cosmic modesty. So if so the idea is basically that like it would be kind of arrogant to think that like we're like the largest civilization in the universe, right?
Yeah, it would be arrogant, because we know that somewhere between a few percent to 100% of all the stars like the sun have a planet like the Earth next to them. And so the dice of intelligence was rolled billions of times just in the Milky Way galaxy. And what's the chance that we are the smartest that ever existed? It's very small, and most likely they predated us, because the sun is a relatively late star. Most stars formed billions of years before the sun, so they already existed. And in fact, the sun will boil off all the liquid water on the surface of the Earth within 1 billion years. And therefore, if there was a civilization on a habitable Earth-like planet around a star that formed 5 billion years before the sun, that form of life was already destroyed by their star burning up the surface of the planet after it went through the same phase that we will go through in 1 billion years. So we were not around to hear their cries for help when that happened, and probably there was an exodus of a lot of spacecraft leaving that planet, and these spacecraft could be found in interstellar space, and we just need to look for them.
I think someone is in the waiting room.
Oh, let me see. In fact, I can return the hosting privileges. Maybe I'll give it to you, Likit.
Yeah, that's fine.
Okay. Okay, so you can go ahead and admit whoever is there. Okay, any other questions?
I was just wondering what inspired you to start researching about the search for extraterrestrial life?
Yeah, I was never fascinated by science fiction. I don't like science fiction, but It was this object, Oumuamua, that looked really strange and weird that I talk about in my book, Extraterrestrial. And I just, I didn't want to surrender to the popular view that it must be natural. I said, well, if it's the first object we identified from outside the solar system and it looks so weird, doesn't look like a comet and looks very different from the typical rocks that we find in the solar system, maybe it's artificial. So that's what started me on this path. And then we discovered with my student, Amir Siraj, we discovered 2 meteors that came from outside the solar system, and they appear to be tougher than all the space rocks in the solar system. So again, why would the first interstellar meteors look so unusual? And so it's basically from the evidence that I was driven to discuss it. And most of my colleagues, even though there is evidence to propose that these objects are unusual, they want to insist that they must be natural. So, for example, with Oumuamua, the suggestion is maybe it's a dust bunny, just a cloud of dust particles that are very loosely bound, that is 100 times less dense than air. And when it reflects sunlight, it gets pushed like a cloud, like a feather. And the problem with this idea is that such a cloud, when it gets close to the sun, as Oumuamua did, would get heated by hundreds of degrees and will not maintain its integrity if it's very fluffy. So then there was another suggestion, maybe it's a hydrogen iceberg, a chunk of frozen hydrogen or a chunk of frozen nitrogen, so that when it evaporates, we can't see the cometary tail because these gases are transparent. And there are problems with these, both of these suggestions, that such an object would not survive the journey. And in fact, there is not enough nitrogen, solid nitrogen, in the Milky Way galaxy to account for a large enough population like that. So my point is, we must allow for the possibility of technological origin, because these objects are so weird. And no matter what, we could learn something new if we take a close-up photograph of them in the future. And that's what the Galileo project hopes to do.
All right, thank you.
All right, if no one else has any more questions, I just have one final question to wrap it up. Do you think more students, especially high school students like us, should look into research as a career? And if so, what avenues are there? Like, for example, if someone like me wanted to work for you and do research on the Galileo project, what steps could they take to achieve that goal?
Right. So once you're admitted to college, we have internship programs that you can get engaged in, and that includes within the Galileo project or just in astrophysics more generally. And you can find them on the website of the Center for Astrophysics and apply to them once you become an undergraduate after high school. I think research is fascinating because you can learn something new. Most of the time people brag about what they already know. And most of the time if you look at politics, you find politicians not paying attention to evidence. They just want to promote an idea that has no support by evidence. And the beauty of science is you are allowed to say, I don't know, if you don't have enough evidence. So science is a very honest endeavor, and you can follow your childhood curiosity and ask difficult questions and try to answer them yourself by collecting evidence. And that's what the Galileo project is doing. That's what I did throughout my career. And it's really an amazing job to be a scientist, because you can follow your passion. Whatever is the question that is most exciting for you, you can explore. So anything about the universe, we don't know what most of the matter in the universe is. We call it dark matter. Maybe one of your generation will discover what most of the matter is. We don't know what's inside a black hole, which is a very, it's the most extreme structure of space and time. It's the ultimate prison from where you cannot escape. We know that black holes exist. We just don't know what happens in their center, because for that, we need to unify the theory of gravity that Einstein formulated with the quantum mechanics. And again, your generation may be the one to solve that. So I would say that the scientific knowledge that we have is just an island in an ocean of ignorance. And there is so much to learn about the universe. It's really fascinating. And, I dedicated decades for that. And I really think of myself as still a kid, a young person trying to figure out the world. And this is the kind of job where you don't need to pretend that you're an adult. You can pursue what you find is your passion and try to answer it using evidence, collecting evidence, just like a detective story. So I would very much, anyone interested in science, I think that's the most exciting thing you can do. Of course, you can have other ambitions in life. You can decide that you want to help other people in various ways, by becoming a medical doctor, by developing vaccines, by all kinds of ways. But science is doing that, actually, because even if you just think that you're exploring gravity, let's say, it turns out that it helps people, because now what Einstein did about his theory of gravity is used to develop GPS systems for navigation. That's what Einstein did is necessary for the precision that when you have navigation in a car, that's using, the communication with the satellites is using the information we know about how gravity curves space and time. And that's really necessary to get the precision. Everything we do with cell phones, with computers, is based on what we learned from quantum mechanics. Without understanding that, we wouldn't be able to do that. So what I'm trying to say is that scientific knowledge leads to advances that eventually translate to technologies that help people. So no matter what you do in science, eventually you are helping people. And at the very fundamental level, if you are curious about how we came to exist here on Earth, then exploring the universe is the best thing to do, because it gives you a bigger perspective about and in that context, finding whether there are extraterrestrials, I think, will have huge impact on the way we think about ourselves, about our future, our aspirations to in space, about our religious, philosophical beliefs. So everything will change if we find it. And I very much hope that this will happen in the coming years. And one of you will help us. So once you finish high school, please apply and or contact me, and I'll be glad to help.
All right, thank you very much. I really like how you relate like spirituality, honesty, and humility into science, because I also really like philosophy and how that relates to science as well.
Yeah, that was my first passion, philosophy and the humanities. But you can bring it together, and just don't be. One thing you have to understand about life is that there are many people who are not creative, that are not imaginative. And out of jealousy, very often they try to step on every flower that rises above the grass level. And the important lesson that I learned in life is to ignore such people and just do what you find your passion, and don't pay attention to people who are negative, basically. That's the most important lesson. And also don't lose your curiosity. Don't try to pretend that you know more than you actually know, which is the trait of many people that show off. They want to pretend that they know everything, but they actually don't. So don't fall into these traps. Don't waste your time with negative people, and don't try to pretend anything. Just follow your passion, and eventually you'll be very happy with what you accomplish.
All right, everybody, that was all that we had for you guys today. Thank you so much, Dr. Loeb, for taking the time to, just tell us about the work you do. It was really interesting, to hear about your work, and also hear about your, ideas about life. Yeah, it was just very fascinating. And for everybody else, thank you for attending today. I hope you all enjoyed it and got to learn more about Dr. Loeb's work. Thank you and have a great day.
Thank you. It was a pleasure. Bye-bye.
Bye.